Okay, so we're going to pick up on chapter 17, talk about air masses and then weather. So an air mass is a large, horizontally uniform body of air. Think of it kind of like a blanket. In this blanket or in this air mass, the moisture and the temperature conditions are nearly the same. So if it's cold, it's cold. If it's warm, it's warm. If it's dry or if it's full of moisture. So there are four main types. You can see here the orange is the outline of the United States, of North America and Central America, and then there's different types of land air masses around the United States. So the four main types are continental polar, maritime polar, continental tropical, and maritime tropical. So in order to know what the mass is made up of, you have to break down the word. So continental is going to be something that originates over a continent. Maritime is going to come from over a body of water. And then polar is cold and tropical is warm. So based on that, you can see that they're originating from places you would expect them to. The polars are all coming from the North Pole, the tropicals are all coming from the South Pole, and if there's moisture, it's going to come from the maritime, and if it's dry, it's going to come from continents. So the movement of air masses is what's going to dictate our weather. The weather conditions remain the same for several days, but any weather changes we have are usually because of a new mass moving in and the local area having to adapt the new conditions. So what this brings us are weather fronts. These are our highs and our lows that we hear about on the news. So the weather front is the boundary between air masses that are at different temperatures and sometimes different conditions. So we're going to talk about a few different types. The cold front is where we have the city here, the cold air mass is moving in. Because the cold air mass moves into, it will displace the warmer air upward, right? Because the hot air rises. So it's going to push the warm air up. This moist rising air will cool and will lead to large cumulus and thunderclouds. So before a cold front blows in, sometimes we have stormy weather. And sometimes the stronger the cold front, the faster it moves in, the more intense the weather. A warm front, on the other hand, is where you're going to have warm air moving in and it's going to advance over a cool air mass. So it's basically just going to plow over the cooler air mass. It's going to have a long, gently sloping front. So sometimes we'll see clouds and rains for days before the front comes in. Tends to be more like flooding type rain, not so much severe storms, but sometimes there can still be storms depending on the instability of the environment. Now, a stationary front, on the other hand, is going to be where we have forces influencing the warm and cold air masses become balanced and it kind of holds off there. Sometimes these are where we have the periods of lots and lots and lots of rain that causes problems in Bossier City. I think 2 or 3 years ago now, they received so much rain that there was intense flooding. And that's because the air masses were both of equal power and just kind of stalled out over the area and just dropped a lot of rain. So now let's talk about what the high and the lows mean. A high pressure system and a low pressure system are also defined as a cyclone and an anticyclone. So a cyclone is a low pressure area. It's kind of like having a vacuum over you because the area is going to pull up the air around that area with inflowing upward forced winds. And this is where we have our tornadoes, our hurricanes, our bad weather tend to be associated with the lows. The highs, on the other hand, is the anticyclones. It's going to be a high pressure area where the warm air is rushing down to the surface. The air sinks, it's warmed, relative humidity is lowered. These are the really beautiful, cloudy, wonderful days, but sometimes they're also the warm days. So during summer, Texas tends to get covered in a high pressure area that we're kind of stuck with until these low pressure systems can gain enough momentum to come, and that's when we start to experience fall and the nice cool October weather that we sometimes get. So a storm is a rapid, violent weather change, often associated with a frontal passage. So these frontal boundaries we just talked about. There are three main types of storms, major types of storms according to your book: thunderstorms, tornadoes, and hurricanes. So a thunderstorm usually will develop in a warm, very moist, unstable air. So those are the ingredients for a thunderstorm. There are three stages to a thunderstorm: the cumulus, the mature, and the final. And storms can be reborn. So storms that tend to be hazardous can gain enough momentum to then flare up again and then die off and flare up again. So it helps identify the really dangerous storm cells. The cumulus stage is kind of the early beginning baby stage. The mature is where we would have the tornadoes, the hail, the heavy rain, the lightning. And the final stage is the dying out, using up all the fuel in that area where the storm would then lose its intensity. Now, along with thunderstorms, we have a phenomenon called lightning. This is discharged between charged centers, so we have an unequal distribution of positive and negative charges between either the ground, the air, the clouds, a particular object, and you're going to have a discharge that will result in a flash of light and then a thunder. So discharge can either be cloud to ground, ground to cloud, or cloud to cloud. So there's different types of lightning depending on where it originates and where it strikes. But the expanding pressure wave from that heated air produces the crack of thunder. And so normally you can use the relationship between lightning and thunder to tell you how far you are from the intense storm. Once it lightnings, you count 1, 1,000, 2, 1,000, 3, 1,000, 4, and you count until you hear the thunder. And that tells you about the distance between you and the thunderstorm. You can use it to monitor it as it gets closer and then as it moves away from you. So it's something I encourage you to try to do next time you are in a storm and you're safe. So hail is a frozen precipitation. It's irregular, spherical, or flattened forms of ice. And it's alternating layers of clear and opaque ice. And the way that hail forms is way up in top of the cloud. You'll start to have water droplets that will pass through really hot and cold layers of the storm. And as they pass through those hot and cold layers, they melt, freeze, melt, freeze, melt, freeze. And the more time that they travel down, the more melting and freezing that they do, the larger the hail becomes. If it only passes through a small portion of cloud and only freezes and melts a couple of times, it might be like pea-size hail. But the softball-size hail comes from storms that are really, really, really intense. They're very, very tall storm clouds, and the hail originates way up in the atmosphere and then melts and freezes lots of times before it hits the ground. So hail is a good indicator of the strength or the intensity of a storm. Tornadoes are the smallest, most violent weather disturbance we have. It's a rapidly whirling column of air. It's a lot like a vacuum because it will suck up everything that it passes around. The diameter of a tornado can be anywhere from 100 to 400 meters. The wind speeds we've measured up to 480 kilometers per hour. We all know that tornadoes can produce very high winds, and damage is due to the high winds. Sometimes damage is due to flying debris, but also there's a pressure drop at the very center of the tornado, that whirling column of air. And tornadoes are associated with very intense storms. Thankfully, meteorology is able to predict the storms that have the right ingredients, but they very rarely can predict the intensity of the tornado, but they can usually predict if a tornado is likely. But there's no telling if it's going to be a small, short-lived tornado or a large, long-lived tornado. And even then, they don't always get it right, because we're going to talk about some of the problems with weather predictions. Now, Tornado Alley historically has been considered to be the Midwest, so up through Oklahoma, the plains of Texas, Kansas. However, in the last 30 years or so, we've seen a shift from that Central Plains area to where now the Tornado Alley, or several tornadoes, are now being produced over the Mississippi Valley. So East Texas is in that, Louisiana, Arkansas, up to Chicago, places like that, where historically Tennessee tornadoes weren't an issue, but it's been a 30-year trend. And so if it seems like we have a lot of tornadoes here in East Texas, you're not crazy. There are quite a few. So the last type of storm we're going to talk about is a hurricane. But to talk about hurricanes, we need to talk about the predecessors. So all hurricanes tend to start off as a tropical depression. It's an area of low pressure where the winds are generally 55 kilometers or less. A tropical storm is going to be a more intense low pressure area. So the winds will be anywhere from 56 to 120 kilometers per hour. And then a hurricane system is a very intense low pressure system where winds will be in excess of 120 kilometers per hour. So the image you see here on the satellite is an image of a hurricane off of the west coast of Mexico. So that's Baja right there. You can see the very well-developed eyes, the bands of the storm. So even though tornadoes are our smallest disturbance, hurricanes are significantly larger, but their damage isn't necessarily destruction due to, well, it is due to winds, but the rain and the wind, the combination of the two is what really makes it quite dangerous. So in a hurricane, in the eye of the hurricane, it's calm, and the wind direction will change. So as a storm is blowing in, the wind will blow out, and then as the storm passes, then the wind will shift directions and blow the other way. So it's kind of an interesting phenomenon, but it tells you where you are in the path of the hurricane. Now, the worst place to reside on a hurricane is on the western side of the hurricane. So we're going to stop here, and we'll talk about weather forecasting at the beginning of next time when you're going to move into chapter 18.